The question here is to solve this inequality, which is mod x minus 1 less than equal to 5 and mod x as greater than equal to 2. We know that when mod x is less than equal to a, x belongs to minus a to a. That means the value of x here will be all points from minus a to a. So when mod x minus 1 is less than equal to 5 implies that the value of x minus 1 is from minus 5 to 5. On simplifying, we get x greater than equal to minus 4 and less than equal to 6. Next, we have mod x greater than equal to 2. So we know that for mod x greater than equal to a, x is less than equal to minus a and x greater than equal to a. So using this, we can say that x is less than equal to minus 2 or x is greater than equal to 2. Now comparing these two number line, we can say that the common point for x is minus 4 to minus 2 union 2 to 6, both inclusive. In this question, we have to find the solution set for mod x minus 2, which is greater than equal to 1 and less than equal to 3. We know that for mod x greater than equal to a and less than equal to b, x belongs to minus b to minus a or a to b. So using this, we can say that x minus 2 belongs to minus 3 to minus 1 or 1 to 3. Now simplifying the first inequality, we get the values of x as from minus 1 to 1. And on simplifying the other, we get the values of x as 3 to 5. Therefore, x belongs from minus 1 to 1 union 3 to 5. The question here is to solve this inequality, which is x minus 2 whole modulus divided by x minus 2, which is greater than equal to 0. This is a rational function and we know that here x minus 2 should not be equal to 0. So from here we can say that x is not equal to 2. That's its domain. The next thing we are going to do is to redefine this modulus function. For that, first we need to find its critical point or the turning point, which is x is equal to 2 in this case. So therefore we can say that for x greater than 2, this is going to be positive, that is positive of x minus 2, and for x less than 2, it is going to be negative of this, which is negative of x minus 2. Now case 1, when x is greater than 2, we have mod x as x minus 2. So we can replace this with x minus 2, positive x minus 2, that whole divided by x minus 2 in the denominator. So it gets reduced to give you 1. And we know that 1 is greater than equal to 0. Now from here we can say that x greater than 2 satisfy this inequalities. Now in case 2, when x is less than 2, we have mod of x as negative of x minus 2. So if I replace this with negative of x minus 2, this results to give you negative x minus 2 over x minus 2. And this can be reduced to give you minus 1. But minus 1 is not greater than equal to 0. Instead, it is less than 0. So we'll say that x greater than 2 does not satisfy this inequality. Hence, the correct answer for this will be x greater than 2. Or you may write this as 2 to positive infinity. The question is to solve the following inequation and represent the solution on the number line. And here it is, x minus 1 over x plus 1 is greater than equal to 0. Now we know that two number in fraction is greater than equal to 0. There are two cases arises when both are positive, because positive and positive is positive, or both are negative. As you know, minus and minus is plus only. So now we are going to break them in the case when both are positive. In that case, x minus 1 is greater than equal to 0. And as you know that this cannot be 0, so we'll be writing x plus 1 as greater than 0. Simplifying this, we get x greater than equal to 1. And simplifying this, we get this as greater than minus 1. Now if I draw a number line over here, and writing minus 1 here and 1 here. This is negative infinity and this being positive infinity. And this is greater than equal to 1 implies including 1 to positive infinity. Another is greater than minus 1. So it is minus 1 to positive infinity. So we can say that the common reason is, or the common part in the number line is from 1 to positive infinity, 1 inclusive. Now, in case to when both are negative, we can say that x minus 1 is less than equal to 0 and x plus 1 is less than 0, as this cannot be 0. This results to give you x as less than equal to negative positive 1, sorry, and this is less than equal to minus 1. Now in this case, it is less than equal to 1 means it is 1 inclusive to negative infinity, and this is less than minus 1. In this case, it is minus 1 is not included, but from minus 1 to negative infinity. So therefore, in this case, the common part will be minus 1 to infinity. Well, minus 1 is not included. Therefore, we can say that x belongs to negative infinity to 1, 1 not inclusive, union 1 inclusive to positive infinity. In the next part, we have to solve this inequation. Now, this is x minus 1 over x plus 1 greater than equal to 1. And what we know that here this cannot be 0 implies x cannot be minus 1. Now, first we are going to simplify this by transposing this 1 on the left hand side, so it's minus 1 greater than equal to 0. Now on taking LCM, this is what x plus 1 and this is x minus 1 multiplied by x plus 1 results to give minus x minus 1 greater than equal to 0. So here x and negative x get cancelled, so we get this as negative 2 over x plus 1 greater than equal to 0. Now dividing this by negative to both sides, as you know, by dividing with a negative number, the inequality get reversed. So we'll get this as positive x plus 1 and the inequality will reverse to be less than equal to 0. So we know that here this fraction will be negative only when this is negative, as the numerator is 1. So we can say that this is, and this is less than 0 and not less than equal to 0, because this cannot be 0. So we can say from here that x is less than minus 1. So therefore x belongs to negative infinity to minus 1, where minus 1 is not included. Now two more parts over here where we have to solve the following system of inequalities and then represent them on the number line. So in the first part we have to solve for x. Now first we are going to take LCM of the denominators, which is 8 in this case, and we'll be multiplying each term with 8. So this is 8 multiplied by 5x over 4 plus 8 multiplied by 3x over 8, and this is 8 multiplied by 39 over 8. So what we can see that here 8 and 8 get cancelled, this 8 to get cancelled, and this is 4 1 times, 4 2 times. So this is 5 into 2, that is 10x, this is 3x, and which is greater than equal to 39. So this is 13x greater than equal to 39, implies x is greater than, it's not greater than equal to, is greater than 3. So we'll say that for the first part x is greater than equal to 3. Now similar to the first part, here also we will be fine. Now in the next part we have this as the question. So here too we are going to take LCM of these denominators, that is 12, 3 and 4. LCM is 12. So let's multiply each term by 12. So this is 12 multiplied by 2x minus 1 over 12. Similarly, this is 12 multiplied by x minus 11 over 3, which is less than 12 multiplied by 3x plus 1 divided by 4. So if I reduce this here, 12 and 12 get cancelled. This is 3 1 time and 3 4 times, 4 1 times and 4 3 times. So how much is this? This is 12x No, this is 2x. This is 2x minus 1. And if I open this bracket, it will be multiplied by minus 4. So it's minus 4 times x, positive 44. And this is less than 9x plus 3. Now this is 2x plus, sorry, this is 2x plus 4x, that is minus 2x. And if I transpose 9 to the left hand side, this is negative 9 is less than, this is 3. And this is how much? 43. On the other side, it will be negative 43. So this is negative 11x is less than negative 40. And if I divide by minus 11, this is 40. Yeah. If I divide by minus 11, the inequality will get reversed. So it will result to give you 44 over positive 11. We divided by negative 11 both sides. So the inequality get reversed in this case. So the answer for the second part will be x greater than 44 over 11. The question is to solve the following inequation. The first thing we'll do is to rewrite the equation as 3x square minus 4x minus 4 greater than equal to 0. Next, we'll find the root using quadratic formula. This is minus b plus minus under root b square minus 4ac divided by 2a. So we get x equals minus b is minus 4, so it is positive 4 here, plus minus under root b square, that is positive 16, minus 4 times a is 3 and b is negative 4, so I'll make this positive to write this as negative 4. That whole divided by 2 times a, and 2 times 3 is 6 here. So on simplifying, we get this as 4 plus minus, this is 16 and this is 48, that is 64. Under root 64 is 8. So I can write this as 8, this as 8 divided by 6. So we get x equals here as 4 plus 8 is 12. 12 divided by 6 is 2. And the other root is 4 minus 8 is minus 8 divided by 6 is minus 2 over 3. Now let's represent this on the number line. So this is negative 2 over 3 and this is positive 2. Now what we can observe here that the coefficient of, look into this inequation, you can see that here the coefficient of x square is positive, therefore it is an upward parabola. So here it is greater than equal to 0. So we can say that inequation is satisfied when x is less than the smaller and greater than the bigger solution. Therefore, the solution, if we write in the interval notation, this x belongs to negative infinity, this is negative infinity and this is positive, negative infinity to minus 2 over 3, there is an greater than equal to, so we'll enclose within a square bracket, and from 2 inclusive, that is 2 inclusive to positive infinity. The next question is this is 5 times 2x minus 7 minus 3 times 2x plus 3 less than equal to 0, and the other one is 2x plus 19 is less than equal to 6x plus 47. Now from here, if I open this bracket, this is how much? 5 into 2 is what? 10 times x minus 5 into 2 is 35 minus multiplying this is negative 6x, and this is minus 3 into 3 is minus 9, and that is less than equal to 0. So 10 minus 6 is how much? 4x, and this is how much? Minus 44 is less than equal to 0. This implies 4x is less than equal to 44, or x is less than equal to 11. So this is one solution we got for this. Now let's solve the other one. So here what we can see that if I transpose 6 to the left hand side, so this is 2x minus 6x is less than equal to 47, and transposing 19 to the other side, it is minus 19. So this is negative 4x is less than equal to how much it is? Negative 28. Now dividing by minus 4, the inequality will get reversed. So it will be x greater than equal to, reversing the inequality over here. And what I can see that greater than, yes, so on dividing by this is dividing by -4, and this is how much? 7. So this is x greater than equal to 7. So we just have to solve this and not to represent on the number line. So we'll say that x greater than less than equal to 11 and greater than equal to 7. Now in this question, in order to find the solution set of this system of inequalities, we need to solve each inequality separately. Like we'll be solving this first and then these two separately. Now taking LCM, this is 15 multiplying by 15 both sides. This is 15 times 2 minus 3x over 5 is less than 15 times 1 minus x over 3. So 5 1 times 5, 3 times, 3 1 time, and 3 5 times. So this is 6x, sorry, this is 6 minus 9x. And this is 5 into 1 is 5 minus 5x. Now keeping on the left hand side, this is how much? This is negative 9x plus 5x. On the other side, this is 5 minus 6. This is negative 4x is less than negative 1. So on dividing by negative 4, both sides the inequality will get reversed and we are getting x greater than 1 over 4. This is what is the other part. So it is 1 minus x over the second solution set. This is 3 plus 4x over 2. Now multiplying by the LCM, which is 6 in this case. So this is 6 multiplied by 1 minus x over 3 is less than 6 multiplied by 3 plus 4x over 2. This is 3 1 times and this is 3 2 times. 2 1 times and 2 3 times. So this is 2 multiplied by 2x and this is 9 plus 4 into 3 is 12, 12x. So finally we can write this as negative 2x, negative 12 less than 9 minus 2. So this is negative 14x and this is positive 7. So on dividing by negative 14 both sides, the inequality will reverse and this will be 7 divided by negative 14. So I can write this as minus half. This is minus half. So we can say that this is our second condition. Now we have two conditions. First is x greater than 4 and the other is x greater than minus half. So for both conditions to be true, x must be greater than the larger of the two. So we can also justify by using the number line. What we can say that if it is negative half and this is positive 1 over 4. So what you can observe that, so the common solution for both will be x greater than 1 over 4. So the final answer will say that the final answer will be x greater than 1 over 4. So we can write x belongs to 1 over 4 not included to positive infinity. In the next part, we have to solve this and this two inequations simultaneously. So in the first part, if I transpose 2 to the left hand side, I can write this as what? 4x minus 2x is greater than 3 plus 7, transposing negative 7 to the other side. So this is how much? This is 2x greater than 10. So x is greater than 5. Now in the next part, we can multiply both sides with the LCM of this, and that LCM is how much? 15 in this case. So this is 15 multiplied by x minus 1 over 3 is less than x minus 3 over 5, and that multiplied by the LCM, which is 15. So we can reduce this by 5 times. This is 3 1 times and 3 5 times, and this is 5 1 time and 5 3 times. So we get this as 5x minus 5 less than
This is 3x minus 9. Finally, we can write this as 5x minus 3x is less than minus 9 plus 5. And this is how much? 2x. And 2x is less than negative 4, or we can say x is less than negative 2. Now what you can observe here, that is the first inequality, that is x greater than 5, and the second inequality, which is x less than. So this is x greater than 5 and this is x less than 2. So we can see there is no value of x that can satisfy both the conditions simultaneously, as there is no overlap between the x greater than 5 and the other as x less than negative 2. So therefore, there is no solution for this system of inequalities.